Here we'll discuss the mean value theorem. So let's look at the hypothesis of the theorem. If f is a function that satisfies two conditions, the first condition being that f is continuous in a closed interval ab. So the closed interval includes the endpoints. So it has to be continuous everywhere in the interval ab, including the endpoints. And the second condition says that the function is differentiable in the open interval ab. It doesn't have to be differentiable at the endpoints, but it should be differentiable everywhere in the interval ab, which means that f prime of x, the function which is the derivative f prime of x, exists in the open interval ab. Then we can conclude, so this is the conclusion, that there is at least one point within that interval ab such that the derivative of the function at that point is equal to f of b minus f of a divided by b minus a. Now let's see what this means geometrically. Here I've sketched the graph of a function f that satisfies the two conditions in the hypothesis of the mean value theorem. So we have a curve, a smooth curve. So the function is continuous. What I've sketched here, the function is continuous in the closed interval ab, including the endpoints. It is a smooth curve, so it is differentiable everywhere in the interval ab. It is not differentiable, this particular example, it is not differentiable at the endpoints. So it satisfies the two conditions of the mean value theorem. So if the two conditions of the mean value theorem are satisfied, then we can conclude that there is at least one point within the interval. And in this case, you can see that there is a point C at which we draw the tangent line to the curve, and the slope of the tangent line is, by definition, the derivative of the function at that point, which is f prime of c. So the slope of the tangent line is equal to the slope of the line joining af of a and bf of b, which are the two endpoints. So the slope of the tangent line at C is a point within the interval AB, equals, so there is at least one such point, equals the slope of the line joining AF of A and BF of B. So slope of the line M joining 2 points, x1, y1 and x2, y2, we know is y2 minus y1 divided by x2 minus x1. So the 2 points here are af of a and bf of b. So that's f of b minus f of a divided by b minus a. So the slope of the tangent line at this point C, there is such a point where the slope of the tangent line f prime of C is equal to the slope of this line joining the 2 points af of a and bf of b. So this is the mean value theorem. Now the Rolls theorem is just a special case of the mean value theorem. So in the Rolls theorem, f is a function such that it satisfies not 2 but 3 conditions. So there is an additional condition. So it satisfies one, which is f is a continuous function in a closed interval ab. 2, f is a differentiable function in the open interval ab. And 3, there's an additional condition, f of a is equal to f of b. Then we can conclude that there is at least one point C in the interval a comma b such that f prime of c is equal to f of b minus f of a divided by b minus a. And it's the same conclusion, except that the numerator in the Rolls theorem becomes 0 because f of b equals f of a. When you subtract one from the other, you get a 0. So basically, Rolls theorem says that there is a point c in the interval such that f prime of c is equal to 0. And that's because there is an additional condition that says that f of a is equal to f of b. So basically, if we had to sketch the graph of such a function, it would look like this. So this is an example of a function f that is continuous in a closed interval ab. Notice that the heights of these 2 points are exactly the same. This point has coordinates a f of a, and this point has coordinates b f of b. Notice that they're at the same height. So therefore, f of a is equal to f of b. And in this case, we can find a point within the interval AB such that the slope of the tangent line at this point, C, is by definition f prime of C, is equal to the slope of the line joining these 2 points. Since they are parallel lines and also horizontal lines, the derivative or the slope of the line joining these 2 points is equal to 0, and therefore f prime of C equals 0.